Well then, let's proceed to the next part, which is my favorite part, which is circles. Now we have learned this in our previous grades also. So what I'll quickly do is run you through all those videos again so that everything can be refreshed in your minds. After having learned about basics of circles, the properties of circles and the theorems related to circles, let me talk about one of my favorite theorems. It is called as theorem 2:1. And here is it stated. It states that the angle a chord subtends at the center is twice the angle it subtends on the circle. To help you understand this theorem, let me first draw a circle for you. So this is a circle. I have a chord AB here. I mark it with dotted lines. I have a center O here and I have a point C on the top of the circle. Now my point C is fixed. Now what I do is I extend lines from A and B to the center. So this is an angle, let me name it as 2x. Again I extend the lines from A, B to C. And this angle I name it as x. So the theorem states this: the angle that the chord AB subtends at the center is twice the angle it subtends at any point on the circle. Fantastic. Now let me copy this figure and paste it here, and let me play around with the size of the chord AB and see how the figure changes. So I have the chord here, I gradually shift it to this point. You see how the angle has increased? That means angle AOB is larger now, and so is my angle ACB. Let me again copy this and paste it there. I gradually increase it so that it becomes the diameter of the circle. At this point, what is my angle AOB? It is nothing but 180 degrees. What will be my angle ACB? That will be 90 degrees, and this we have already studied in a previous grade. The angle in a semicircle is 90 degrees. Now, again let me copy this and paste it there. Now let me again shift the chord or the diameter to this level. Now can you see that the figure has drastically changed from the original figure? Now which is my angle 2x? Take a moment and think. Well, it is again this angle, right? Don't get confused whether it is this angle or it is this angle. For this, what if I turn this figure back to the original figure? So here I have the original figure. Now watch very carefully what is happening. How the angle 2x is changing. So this was my original figure. Second step, third step, fourth step. What happened? You saw the increase in the angle, and which was the side? It was this side. So this is 2x and this is not 2x. So don't get confused. And your x of course remains the same. So again I copy this and I paste it there. Now let me turn this figure and make it like this. I copy and I paste. I again turn it this way. I copy and paste. I remove the figure which is there now. Now watch very carefully all the 6 figures that you have. Any kind of combination you have on this theorem, it will definitely fall in any of the 6 categories. So don't be afraid of solving numericals based on this theorem. If you can understand how we got these figures, you can easily solve any numerical on this. So let's move ahead and try to solve a few numericals based on this theorem.